creativity mean? What do you think creativity means? Solving problems. What else?
Original thinking.
Original thinking. What else?
Thinking about something new, creating.
Thinking about something new. What else? Yes?
Thinking outside the box.
Thinking outside the box. All of these are properties. But when we speak about creativity, we should make sure that creativity starts with an idea, and it's a full process. It's a whole process that will be developed, and the most important thing, that it will be transformed into a value. If there is no value from the process, simply the idea is not creative. It's just an idea. We should have a value. That's by definition, what does creativity mean? Why it's important? Because mainly here in UAE, we have a very huge problem. Not only here, in many schools in the Gulf and in the Middle East. Because simply, yes, we want 21st century skills. We want our students to foster creativity and innovation. All of these will show us that it is important, especially when we speak about the investment of UAE in a knowledge-based economy. They are paying millions of money. So it's a must, but it's a problem because we are not allowing our students to think creatively because we need them to score higher. These are the problems, that's the curriculum, that's it. There is a standardized test, which is a map, whatever. So simply they are sitting for 1 hour, they are solving problems. So they are doing what we are telling them to do. In addition to that, when it comes to parents, they look at the final average. Not all of them, but most of them. And also teachers, we know what is creativity, but are we implementing it? That's a very big question. How can we implement it? Is it applicable? Is it efficient? We need to answer all of these questions. How can we apply creativity in science? So by the end of this session, I think you will be knowing how to apply it in science and how to foster it in science. Now, I have here 4 of my students. They are students at Ittihad Private School, Jumeirah. They will be distributing now 2 documents. A questionnaire that you will fill and you will give it to me at the end of the session, and also a creativity test. You will be getting a paper exactly like this. You have a lot of circles here. The question is, I want you to turn out these circles into objects, into things that you know. For example, the first one is a sun. I see it as a sun. The second circle, I see it as a full moon. You have exactly 30 seconds. Try to finish as much as possible from these circles. What do you imagine these circles are? I gave you an example, sun, full moon. "30 seconds you have. Five seconds. 4, 3, 2, 1. Thank you. Who finished the 30 circles? All the circles. Raise your hand. Good. Because she's a teacher at our school. Who finished more than 15 circles? Who finished more than 10? Okay. Who completed more than 5? Great. Let's listen to some answers. Yes, what did you get?
Some was ball,
Ball,
like a smiley face,
okay.
and like chapati.
What else? Other answers, please.
Bubble.
Yes, Miss Natalie.
Tire, bubble, candy, pizza, bread, egg, pebble, marble, crystal, sand grain.
Okay.
I made a traffic.
You did? A traffic light. So you
The top of
used
a
3
cherry.
circles. Yes.
I used 4 or 5 circles to make a wave
Good.
and group to make a face.
Good. Or simply you can say that all of these circles are just bubbles. Okay? And you can finish all of these. What I'm trying to say here, the question was, try to turn out these circles into things that you know, or you can imagine these circles as moon, sun, whatever. But I didn't say how. So you need to take the risk. Maybe yes, you can take 3 circles, and this is a traffic light. Or you can make like a snowman from 7 to 8 circles. So you can finish in 30 seconds all the circles. You can draw a car, and so on. That's our problem with our students. We tell them what to do. If we give them the freedom, yes, we will getting different answers, but again, that's not creativity. In order to be a creative answer, it must have value. If there is no value, it's not creative. Let's watch this video. It's for Ken Robinson. He's the best man who speaks about creativity. Let's see the video. After that, we'll continue.
Great study on recently of divergent thinking. Published a couple of years ago. Divergent thinking isn't the same thing as creativity. I define creativity as the process of having original ideas that have value. Divergent thinking isn't a synonym, but it's an essential capacity for creativity. It's the ability to see lots of possible answers to a question, lots of possible ways of interpreting a question, to think what Edward de Bono would probably call laterally, to think not just in linear or convergent ways, to see multiple answers, not one. So I mean, the test for this, I mean, one kind of common example would be, people might be asked to say, how many uses can you think of for a paperclip? Well, those routine questions. Most people might come up with 10 or 15. People who are good at this might come up with 200. And they do that by saying, well, could the paperclip be 200 foot tall and be made out of foam rubber? You know, like, does it have to be a paperclip as we know it, Jim? You know. Now, the testers, they gave them to 1,500 people in a book called Breakpoint and Beyond. And on the protocol of the test, if you scored above a certain level, you'd be considered to be a genius at divergent thinking. Okay? So my question to you is, what percentage of the people tested, of the 1,500, scored at genius level for divergent thinking? Now you need to know one more thing about them. These were kindergarten children. So what do you think? What percentage at genius level? 80. 80, okay. 98%. Now, the thing about this was it was a longitudinal study. So they retested the same children 5 years later, ages 8 to 10. What do you think? 50? They retested them again 5 years later, ages 13 to 15. You can see a trend here, can't you? Now, this tells an interesting story, because you could have imagined it going the other way, couldn't you? You start off not being very good, but you get better as you get older. But this shows two things. One is we all have this capacity. And two, it mostly deteriorates. Now, a lot of things have happened to these kids as they've grown up. A lot. But one of the most important things that happened to them, I'm convinced, is that by now they've become educated. They know they've spent 10 years at school being told there's one answer, it's at the back. And don't look. And don't copy, because that's cheating. I mean, outside schools, that's called collaboration. No, but inside schools. Now, this isn't because teachers want it this way, it's just because it happens that way. It's because it's in the gene pool of education. We have to think differently about human capacity. We have to get over this old conception of academic, non-academic, abstract, theoretical, vocational, and see it for what it is, a myth. Secondly, we have to recognise that most great learning happens in groups, but collaboration is the stuff of growth. If we atomise people and separate them and judge them separately, we form a kind of disjunction between them and their natural learning environment. And thirdly, it's crucially about the culture of our institutions, the habits of the institution and the habitats that they occupy.
Okay. That was an interesting video. What he's trying to prove. Now give a tennis ball to a 20 years old man. The first thing that you will think about this tennis ball, he just wants to play tennis. That's it. Maybe he will play basketball. Okay. Maybe he will play basketball with it, but he can create maximum he will create around 2 to 3 games. However, give it to a child who's 4 years old or 5 years old. Every day you will see him playing a different game with his tennis ball. The same what happens here with the paper clip. If you have a paper clip, it's just for papers. For them, no. They can use it to fish, to do different games, to create different games. Why this is happening? Because we are shaping their minds in schools. But are we allowed in schools to foster this creativity without affecting the curriculum? Without getting afraid from KHDA if they want to visit us, because all of these are very important questions. And now I will be answering all of these. Because we need to know that creativity is a skill. It's similar to communication, similar to, let's say, critical thinking, and so on. So from now on, I will start showing you how we integrated creativity in the science curriculum and how can we foster this in our students. So, from this video and from the activity that we did, creative people are able to generate new ideas. Yes, sometimes they make a lot of mistakes, but the most important is to reflect and to know why we were mistaken and how to do it right in the second try. They ask a lot of questions. Why? What? What will happen if? And these are the questions that we ask our students if we want to foster critical thinking. We ask them why, right? What if? They collaborate with each other. They make connections. They take risks. So mainly the students must be risk takers. But should we just leave the court for them and they will do whatever they want? Of course not. Also a reflection on the video. According to Ken Robinson, our students do have creative skills. We need to fully exploit the skill set of critical thinking, communication, collaboration, and creativity in all of our students. Here we go, and we reach the KHDA requirements. What do they need from us? They are asking about attainment and progress, right? And that's from the KHDA booklet. Simply, they are asking us about scientific thinking, practical laboratory skills, ability to draw conclusions, communication skills, and application of science to technology. If we go back to this definition, we will see all of these here. These are the skills that we need in our students. If we teach them how to be creative, 100% the attainment will be higher. 100% the progress will be higher. Because in creativity, we are fostering critical thinking. They will be communicating with each other. They will do a lot of research. They will be facing a lot of critical thinking situations in which they should think sometimes also outside the box. So 100%, if we integrate this into the curriculum, it will help us as educators. So it's an imaginative activity fashioned so as to produce outcomes that has both original and value. And the most important thing is value. When it comes to critical thinking, ability to think clearly, rationally, it includes the ability to engage in reflective and independent thinking. Reflection. Now, how can we apply this? Let's speak about students in grade 8 or in grade 9. Assets and bases. We can explain the lesson, ask them some questions. Is this acidic, is this basic, according to the pH, and so on. However, let's give it in a form of a problem-based learning. Okay. Your granny tells you that when she was young, bee stings were treated with bicarbonate of soda, but wasp stings were treated with vinegar. So it's a real-life problem. The question is, what do you think the pH of the chemical in a bee sting must be? So now I am covering and I am testing my objective, but in a different situation. So now as a student, I need to think. If I'm treating the bee sting with bicarbonate of soda, so the bee sting must be acidic or basic. What do you think?
Acidic.
Why? Because bicarbonate is? Exactly. So now the students will start thinking and analyzing. It's not just giving them a pH which is 5. Of course it's acidic. Yes. It's because I know that a pH of 5 is for acidic solutions. But here no, I'm teaching them how to analyze. Why do you think so? So here I am asking them for why. It's not just an answer. What about the wasp sting? Again, if I'm treating it with vinegar, vinegar is acid, so it must be what? Basic. So they are doing connections. Another example. Mechanic noticed a slight leak from a car battery and some of this liquid accidentally splashed on his hand. That's a situation that may face any mechanic. Right? Can you suggest 2 things he could do immediately to minimize the damage of his hand? And it can happen to the students, to father, to anyone. So simply, we are asking the student to do what here? To think, analyze. What's the chemical used in batteries? Acid. Okay, in the books it's written sulfuric acid. Now how can we treat it? By adding what? Base. So simply what are the bases that are found in our homes? Bicarbonate of soda, for example. Okay, if he adds, let's say, some soap or whatever, but now he's thinking, he's analyzing something that he may face, his father, let's say, might face, or anyone like this. So these are samples of the questions that we can, let's say, ask our students. And now, by the way, if you look at the PISA exams, they are very similar to these questions. It's not only about the content. It's about how to think. They will give you a concept map and analyze. So that's the early step in creativity, in fostering creativity. That's just a presentation. Simply, the lesson was given to grade 12 students, even before explaining the lesson from the teacher. You have assets and bases, go prepare it and come. You cannot imagine in how many different ways students explain the assets. And what did they do in order to prepare all the material that they got from their houses. So also, creativity in teaching is different ways. And all of these ways, they have a value. So also that's creativity. Now let's speak a little bit about the lab work. And here we'll be speaking more about creativity and you will be starting seeing results. Usually, we ask our students to go to the lab. This is the procedure. Follow the procedure and give me your results, whatever, reflect, that's it. Or we'll explain the lesson and we will ask the students to do an experiment, which is an application of this lesson. But till now, even if it's a practical work, it's still an application. They learn just what we taught them, and that's it. Let's take a step back and ask them a question, or ask them the question in a different way. Give it to them as a problem and ask them to solve it. The same way as the bee and the wasps thing. You have, for example, in chemistry, you have a situation in which you have two colorless materials. One of them is acid and one of them is base. And your teacher is asking you to get her the acidic solution. She has a demonstration, she wants to show it to someone, and so on. So what are the different methods that can we distinguish acids from bases? Because we have two options, either to tell them these methods or to ask them to go and search. Usually, in the books we teach them that use pH paper, use indicators, titration, whatever. But if you ask them to search for answers, trust me, you will find solutions that you didn't think about. You will be getting 6 to 7 different solutions. Some of them are in their books, and some of them are not. For example, one of the students, she said that I will be getting names. And if there is corrosion, simply the solution is acidic. If there is no corrosion, it's basic. That's right. And it's not in the book. Other student, he searched and he found on YouTube that he can do it through an indicator that he can create, like doing the cabbage thing, the red cabbage. So he will do it. And he will use his techniques by creating a video and so on. But can we allow these students just to run these procedures and go to the lab and do the experiment? Of course not. So here we have steps to follow. The first step, give them the problem. Second step, they will give you the procedures. Third step, which is the most important step, because in science, rule number 1 is safety. They can go just to the lab, right? Give them the feedback. Because when we speak about nails and solutions, 99% of the nails are galvanized, right? So simply it will not corrode. So here, this is your role as a teacher, to be a facilitator, to put the student on the right track. Give him this feedback. That's very important. After that, if you feel as a teacher that it's safe, and it's 100% safe, now they can go and they can do their own experiments. If we have 6 different experiments running at the same time, that's great. So they are learning different ways and they are all reaching the same result. In physics, for example, simple experiments, simple ideas. How can you calculate, for example, average velocity? I can give you a procedure, or I can ask you to create a procedure. Of course, you will be getting different procedures. So the way you ask your students is very important. But we have a problem. In some schools, let's speak about 60 to 70% of schools, usually students don't take laboratories seriously. Is it right? Why? You said yes. Why?
It's not interesting enough.
Why?
They are not allowed to experiment on their own.
Too many rules, right?
Yeah, too many rules.
What else? So what about teachers? As teachers, also most of the teachers, they are interested in explaining and explaining and explaining theories and solving problems. However, when it comes to the lab, one lab is enough. I need more time. I'm not doing a lot of labs because I need a lot of time explaining. Even teachers are not taking it seriously. So there is a very small solution in which teachers and students will take the lab seriously. The solution is what, Ms. Lara?
Move the class to the lab.
And again, doing what?
More lab activities.
And at the end of this, the students will do a lab exam.
Yeah, a lab exam.
Lab exam. This year we started conducting a final lab. Mainly, let's say the exam is out of 40. So we divided this 40. 10% is for the final lab, and 30% from this 40 is for the theoretical exam. So now, teachers are obliged to go to the lab. Students are obliged to focus, because at the end of this, if they are doing 4 labs during the term, one of these will be given to them as a final lab. And if we have 20 students, they will be getting different experiments. Some of them, they will be given, let's say, with a full procedure, and also you can differentiate in this. Some of the lab exams, you can give it without a procedure if you know that this student, yes, I want to challenge this student. You can give it without a procedure and so on. How to do it? Easily. These are samples of the required materials that you will give to conduct a final lab exam. That's, for example, in grade 7. One of the experiments was about bacterial culture, extracting chlorophyll from plants, preparing, observing a microscope slide. So simply, all the students covered these experiments. They will come to the lab exam. If you are students sitting in the lab, you will be getting the first experiment, you will be getting the second one, you will be getting the third one, and so on. So students will be doing different experiments at the same time. Try it, and you will see that students will be more interested and they will enjoy it more. That's another sample. And of course, you need a rubric. I will try to hurry up. We still have just 10 minutes. That's not my problem. It's a problem for the guy who was presenting before me. We finished late. That's a rubric that you will be using. So a rubric is very important so that the mark is not judgmental. These are some photos from the lab exam. And the teacher will be assessing the students on spot, starting from the safety precautions to the results. Some of the experiments will be outdoor, some of the experiments will be indoor, and so on. Now I will speak about exhibitions and the results from all of these. Ladies, you preferred these. You all heard, I think, about Think Science, right? These are some of the awards that students at Ittihad Jumeirah, they got. Some of them are awards from here, from UAE. Some of them, no, they went to US and they got the second place there. Because of what? Because the students must be prepared for such situations, and they must be given the full freedom to work and think. What we'll be doing now, I will let our students to share their experience. These students are from grade 10 and grade 11. They participated in Think Science. And they will tell you they are much better than me in explaining their project and in telling us about their experience. Let's start with Aisha Zaruni and Mira Al-Hashimi. These are grade 10 students.
Good afternoon. My fellow partner
Mira Al-Hashimi
and I, Aisha Zaruni, are honored to be part of the What Works conference. Now, the encouragement and excitement to get into the Think Science competition came when we saw the success of our fellow friends who had the opportunity before us. And as we knew that we were getting the same opportunity, we got completely delighted by that.
When we first decided to participate in Think Science, we wanted to solve a major worldwide problem, which is global warming. And after researching, we found out that the main cause of global warming is the increase of the amount of greenhouse gases, mainly CO2, in the atmosphere. And once we knew that, we developed our project, which is basically about designing a method that captures CO2 and converting it to other beneficial products by using the atmosphere as a storage and transport medium.
During the whole process, we faced many problems and struggles. We reached some points where we thought of giving up, but our teachers were always there for us. They taught us what we needed. They taught us to be fighters and not quitters. They helped us continue the journey, even after the struggles that we faced. Yes, they were the most exhausting months of our lives, but when we stood in the middle of our booth and looked at where we've reached, we felt the proud and the achievement. Can I call that a victory? Yes, because the experience itself is a gain.
Personally, what I've learned from Think Science is, first of all, to accept criticism and to use that as a stepping stone, not as a degrading factor. And second of all, is to have self-confidence and to never underestimate yourself. Because before participating in Think Science, I never thought that I'd be able to do what I achieved to this day. And academically, I learned how to be creative, how to think outside the box, how to research properly, and how to improve my presentation skills.
My personality changed a lot after this experience. Now, every time I see a problem, my mind directly flows with ideas and solutions that I'd love to try and experiment and invent. I think I'm done with this right now, but no. Wait, I forgot. I almost forgot. There is one thing that's very important to us. my identity, our identities as Emiratis. We now can proudly say that we are confident Emiratis who are confident in making and finding solutions for the problems that we see happening in our country and in our daily lives. Thank you for having me.
Very good. Now, Ruwaida and Rhoda, they will tell us a little bit about their project and about what did they learn.
I'm Ruwaida Rashid from grade 11, and this is my partner. It was our first year participating in the Think Science competition. We heard about it from our teacher who introduced the competition in class. We were really interested. She explained the categories, and we were mainly interested in the energy category. The first thing we did was pairing up with each other. Later on, we started our research, putting in mind that the UAE is a country that lies directly in the Arabian Desert. So we started thinking, what does the UAE have and what doesn't it have? It mainly depends on fuel, which is non-renewable energy. So we needed sustainable energy that will replace this, since non-renewable energy comes to an end one day. And also it's the #1 cause of pollution and many breathing problems. We were thinking of many replacements, and the best replacement was generating electricity from urine. We could have used water, but UAE lies in the desert, which means it's not abundant in water. And by that, we will be reusing this waste and recycling it, as well as reducing the pollution and poverty.
We worked really hard, day and night, in these past few months, and we tested our hypotheses many times, and we failed a lot of times, but we didn't give up. We learned from our mistakes, and we researched more and got new ideas and worked on them. And from how many mistakes we made, we were going to give up, but we tried again and again until we got the results finally. And this experience has made me gain a lot of confidence and more knowledge on the topic, and I also gained skills in presentation and research, and also communicating with others. And now I'm proud of myself from all the positive feedbacks that I got from everyone, and now I'm proud of what I have achieved.
And we can't forget that we can't have done it all without the help of our teachers and principal, who really stood by us, and as well as our parents, who really encouraged us from step one.
And of course, next year we would be participating in the same event.
Thank you.
Thank you, ladies. So, just to give you a brief about their projects. When you find a student, let's say in grade 10, and you're asking him to reduce the emission of carbon dioxide, and that's called chemical engineering now, because their idea was about designing a method, which is, we have the factories and the CO2 is a method, right? So they thought about why they don't have fans, which is a little bit higher than emission of the CO2, in which it will push the CO2 to another vessel, and they can collect this. And again, they thought about some of the CO2 will escape, so mainly they used water in order to dissolve the CO2 and so on, and they designed this. The other group, they spoke about urine, and yes, I saw them many times failing, and they didn't get results till 4 or 5 days before the exhibition, for which, yes, they got the voltage. It's an idea, they worked a lot on these ideas, and they got results. I think that's what we need from our students to do. These are their photos with their principals, teachers, even reporters, they did interviews with them. That's it. Thank you a lot.